Good evening, everyone. So I'm Jane Winchell, the Sarah Fraser Robbins Director of the Dottie Brown Art and Nature Center at PAM and Curator of Natural History, and I'm also the Program Coordinator for ECOC. And so these are hybrid events that we're doing collaboratively with ECOC and PAM. And I am delighted to welcome back Roger Pasquier to PAM. He last spoke at ECOC in 2020 about his previous book, Birds in Winter, Surviving the Most Challenging Season. Before doing his intro, I want to take a moment to thank the ECHO Charitable Foundation for their generous gift, which made this event possible. Roger Pasquier is joining us tonight from New York City, where he is an associate in the Department of Ornithology at the American Museum of Natural History. A native of New York, Roger began watching birds in Central Park at age 7. He also has a deep appreciation for the arts. In fact, he started out studying art history at Columbia and the University of California, Berkeley. Roger has worked at the American Museum and a who's who of other respected institutions, including the Smithsonian, BirdLife International, World Wildlife Fund, USA, Environmental Defense Fund, and National Audubon Society. He has also served as an officer of conservation organizations focused on the tropics, including Rainforest Trust and RARE. He has written several notable books on birds and art history, including Watching Birds, An Introduction to Ornithology, Masterpieces of Bird Art, 700 Years of Ornithological Illustration, and Birds in Winter, among others. His latest book, Birds at Rest, The Behavior and Ecology of Avian Sleep, published this year by Princeton University Press, is the focus of tonight's talk. It's the first book to give a full picture of the important topic of how birds rest, roost, and sleep, including new science on the subject, and includes beautiful illustrations by artist-illustrator Margaret Lafarge. If you'd like a signed or personalized copy of this singular book, please do join the book signing, which will be in the Morse foyer just as you leave the auditorium. And Roger will also be there to personalize at that time. And so delighted again to have you back, Roger, and looking forward to this talk.
Thank you. Thank you, Janie, and thanks all of you for coming on this cold night, because I know you could be watching it from the comfort of home, and I want to welcome all the people who are Zooming. I know my friend John Bitterman is doing this, and Sissy Folliott is. Perhaps there are other people I should be saying hello to who I'm sorry I'm not seeing here in person. Thank you for having a visitor from New York come to speak. It's interesting to hear you talk about birds in Massachusetts, because red-bellied woodpeckers, for example, they came to New York and colonized New York just a few years before you started seeing them here. And I will also add that for the most recent New York Field Notes of Excitement, our interesting birds in the last month have been Arctic warbler and Eurasian cuckoo. So, and I know there were people from Connecticut who came down to see them. I'm not sure whether anybody made the trip for Massachusetts. I'm starting with the cover of this book, which I specially asked Princeton, let's get a photograph of flamingos sleeping on one leg, because that's something so typical of them, and it really talks about sleep. But I want to ask you to think about, why do birds sleep on one leg? It's not just flamingos. A lot of birds do. So after I'm through talking, when I take questions, I'll be happy to hear your ideas of why do birds sleep on one leg. Some of you may have been here 5 years ago, just before COVID, when I spoke about my last book, Birds in Winter. This book came directly out of that, because in that book I had to talk about how do birds get through these very long nights that they have in winter? How do they get through these very cold nights, both physiologically, and what do they do about roosting? Do they roost by themselves, looking for sheltered spots? Do they roost in flocks, in pairs? That's what inspired me to look into this subject in more detail, and that's what I'll be covering tonight. So sleep evolved very early in animal evolution, but we know that because it's present in such a wide range of animals that diverged so long ago and have such different nervous systems. Here is a jellyfish, the Japanese sea nettle. It doesn't have a brain or a central nervous system, but it does every day have a regular rest period when it's harder to stimulate. Here's something called a fuchsia flatworm found in the Indo-Pacific. It's thought to be 839 million years old. It has an early form of brain. It lives either spending its time swimming or in contraction, and when it's for minutes or hours, it's less responsive when it's in contraction than when it's swimming. And other brained animals like crayfish, spiders, insects, snails, and octopus, they also have periods when they are less responsive and then more active periods. Getting into vertebrates, here's an American alligator. Crocodilians are thought to be 235 million years old. They're the closest surviving relatives of birds, although not ancestral. And crocodilians, lizards, and snakes sleep anywhere from 3 to 22 hours a day. So what are the benefits of sleep? Why do we do it? Why do all of these other critters do it? Well, it's the most efficient use of time for the hours in the day when wakefulness is not productive or could even be dangerous. Warm-blooded animals like birds and like us lower their body temperature when they sleep. It's an energy saver, reduces the need for the food that's fueling their high metabolic rate. During sleep, brain strengthens or weakens synaptic connections, creates space for consolidation of learning, organization of memory. In birds, song learning, distinguishing sounds, courtship, danger, and identity are all some of the things that seem to be imprinted during sleep based on experience that they've had while they were awake. And all of these things are best done when an animal is not in the stressful condition of wakefulness. So why do we know so much about sleep in birds? Because now we can put electroencephalogram equipment on them and measure their brain waves that tell us whether birds are asleep or awake and what kind of sleep they're in. And this can be done in labs, and it can be done on wild birds. The key is to be able to retrieve the EEG equipment, so you want to do it on wild birds. Most work on wild birds has been done with birds that are nesting so that the birds will return to the nest and you can retrieve the equipment easily then. So here's what it looks like. This is showing you the brain waves during two kinds of sleep that birds have and we have. The more jagged ones are slow wave sleep, which is low frequency and high amplitude. The finer lines are from rapid eye movement sleep, also known as active sleep, where the brain is more active with higher frequency, low amplitude, and reduced muscle tone. In birds, that occupies about 10% of birds' sleep time, usually lasting 2 to 10 seconds. Remember that birds sleep in much shorter bouts than we do, not through the whole night, but usually in sleep episodes of, let's say, 4 to 6 minutes. They wake up, look around for danger, and go back to sleep. This is something that birds have evolved because they're so much more vulnerable where they sleep, and they need to be alert for predators both at night and by day. Birds have also evolved something else that we have not, which is unihemispheric sleep, where they can shut half their brain at a time. So they can shut, let's say, this half of the brain, and the opposite eye is asleep also, but that leaves one eye and one half of the brain awake so that they can look around for predators or be somewhat aware of what's going on around them during the course of the night. And they rotate every so often between left part of the brain, right part of the brain. The other animals that have evolved this are marine animals, whales and porpoises that need to be sufficiently awake to come up to the surface to breathe again. They do this, and so do some kinds of seals. So let's look at the postures that birds take in sleep. This shows a variety of the postures that the range of birds take, but as you can see, most birds turn their head onto their back and put their bill in the feathers of their back. They do this because it reduces heat loss from the exposed areas that are not covered by feathers. And a lot of birds also tuck their feet into the belly feathers, and that also reduces heat loss. And we know that this is a very ancient posture for sleep, because here is a dinosaur. Let's see if I can work this. Here is a dinosaur that's not ancestral to birds, that was found in China, and it's believed to be somewhere between 128 and 139 million years old. And here in this diagram, here's the head, here's the neck, there it is on the skeleton and the neck, and you can see that it's turned its head and neck over its back in the same way that, that birds do. Birds also yawn. The best studies of yawning have been done with ostriches, which are easy to follow and quite conspicuous. And yawning with them and with us is associated with the onset of sleep, the initial stages of waking, and other transitions as when rest is interrupted or there's a reduction in stress level. I didn't know this, but yawning cools the brain, thereby improving alertness and mental process efficiency. Try it. It's also contagious in birds as it is with us, and it has social functions in that in ostriches, which live in troops, the higher-ranking ostriches are the first to yawn when the occasion is appropriate, and that's a signal that there's an absence of danger and the other ostriches can relax. So birds have their own schedules for resting. We think most birds are spending the night asleep and the daytime active. But what about those birds that live in the very high latitudes, Arctic or Antarctic? So here's a pectoral sandpiper. This is a displaying male. In the high Arctic, this photo, I think, was taken at Point Barrow. At least the studies about this bird were done at Point Barrow. For 3 weeks, when there's almost perpetual light there, the males are spending their time pursuing females, courting them, and inseminating them. And during that period, they sleep as little as 2.5 hours during a night. After that period is over, they sleep longer. But the study at Point Barrow found that the males that slept least were the ones who sired the most offspring. Other shorebirds, like these red knots, and all shorebirds that feed on coastal marshes are governed by tides. The tides expose and then conceal their prey, so they have to adjust their rest times to the high tide hours when they cannot be feeding. So tactile feeders like these knots that can locate their prey just by the sensitive organs at the tips of their bill, they don't need to see anything, they can be out feeding during the night or during the day. So their rest times are shifting every day when they're at tidal situations, taking advantage of the tides and resting in the time when the tides are covering up their food sources. For most diurnal birds, you bird watchers know that the middle of the day is the hardest time to find birds because many of them are resting, particularly in warm weather where they're seeking a cool place where they can rest. These scarlet macaws are spending their time doing mutual preening and other less stressful activities, waiting for things to cool down. Here's a scene in Africa with 3 kinds of vultures: Ruppel's griffin, Eurasian griffin, and hooded vultures. And when they have gorged themselves on a carcass, they are so full they can hardly get up. And so they have to rest there nearby, the safest place that they can find, until they've digested enough so that they can fly again. And this applies to other birds as well. Here's an emerald toucanet from the American tropics. They feed on fruit. They visit a fruiting tree, pluck a few fruits, and then move away from that tree, which of course is an oasis and a magnet for birds that makes them very vulnerable to predation. So they move to other trees where they sit in an inconspicuous spot until they've digested those fruits, which takes 20 minutes to an hour, and then they go back to the tree to feed again. So they're getting a lot of rest during the daytime when they really can't do anything else, as well as all through the night. There are deeper forms of sleep than simply the slow wave sleep and the rapid eye movement sleep that I've mentioned. First, there's hypothermia, which chickadees like this black-capped chickadee and many other birds at high latitudes, small birds, do. They lower their body temperature by about 10 degrees Celsius. I don't know how many of you think in Celsius. I can't except for bird life, but birds' general body temperature during the day is 40 to 42 degrees, which is over 100 degrees, so in Celsius. And the chickadees will lower their body temperature every night by about 10 degrees, and then the body temperature rises at dawn, and they're fully functional again. The benefits of this is that they don't need to eat as much during the day to stoke their engine that keeps them as warm as if they maintained their 100-degree body temperature. So they can feed less during the short winter days that are available to them. The risks are, of course, that they're somewhat less responsive to predation should it come during the night. But the alternative, to feed more during the day, would first expose them to more predators as well as make them less maneuverable. So it's a trade-off for these birds, and many small birds only go into hypothermia on extremely cold nights. Below hypothermia, there is torpor, where they lower their body temperature even more. And this is typical of birds that have very irregular, unpredictable food sources and perhaps unpredictable weather conditions too. So in our part of the world, swifts and nightjars are the ones that enter torpor most often. This is a black metaltail, a hummingbird from the Peruvian Andes. Hummingbirds also enter into torpor. Hummingbirds, of course, are tiny. They live on a diet of fructose and sucrose, not very sustaining over the long term, and they have a tiny body that loses heat so rapidly, so they lower their body temperature much more. This bird's daytime body temperature is 42 degrees Celsius. At night, it goes down to 3.2 degrees Celsius, which is the lowest known for any bird that, or non-hibernating mammal that doesn't actually hibernate. We do have one bird that does hibernate. That's the poorwill. This was first discovered in California in 1946, that poorwills will sleep for several days and nights. The record is 45 days, and they reduce their oxygen consumption by 90%. It's suspected that there may be other nightjars that also do this, but none have been found to do it. So now let's think about where do birds go to sleep. Just as with us, they're looking for a place that's secure and warm. So the first thing they're thinking about is a place that is concealed from predators, and at the same time they're thinking about protection from wind, from rain, and cold. Now the ideal place, just as we occupy, is cavities. So here's the last photograph of the ivory-billed woodpeckers from the Singer Tract in Louisiana in 1935. There may or may not still be ivory bills around. That's a subject that people can argue about for a very long time. So woodpeckers all make holes not just for nesting, but they make different holes for roosting, which are smaller and more of them so they can move around during the course of the winter and not become so well known to a predator that might see them going to the same place evening after evening. And these holes, of course, become the homes of many other birds, like this white-breasted nuthatch, which uses the unused woodpecker cavities, and they're very fastidious. They take their droppings out of the hole then in the morning so that it's clean for them or whoever is using it the next night. There are other woodpeckers that live where there are no trees, like this campo flicker in southern South America. They burrow holes in the ground. Then you have a lot of species of grouse, like this Eurasian capercaillie. They excavate burrows in snow, which, like an igloo, is much more insulated and warmer, as well as protected from or concealed from predators, than if they roosted out in the open, as conspicuous as this bird is, either on the ground or in a tree. And then there are a lot of birds, particularly in the tropics, or non-migratory birds, that live in the same place all through the year and have what are called dormitories, that they build special structures in which they roost, not the same as the nest in which they raise their young. This cactus wren is perhaps the most northerly bird to build dormitories, and every individual cactus wren, from the time that young fledge, builds its own dormitory for use during the non-nesting season. But of course, most birds can't build these things and can't find cavities or can't fit into cavities. So most birds are roosting out in the open, like this long-eared owl. But as you know from trying to find long-eared owls, they are very skillful at finding places that are extremely inconspicuous. The owls, of course, are using them by day, but you should also remember that most owls do most of their hunting when there is some light in the evening and more or less around dawn, and are resting for much of the darkest hours of the night as well. So most birds are looking for a place that is sheltered from wind, rain, and cold in deciduous trees or coniferous trees if they have them in their range. There are other birds that are looking for just the opposite. If you were a bird like these Heermann's gulls and brown pelicans on the California coast, you'd be in essentially a two-dimensional environment. You'd be looking for the place that is most exposed, most out in the open, so that you are farthest away and most easily able to spot any approaching predator. So they're very deliberately looking for places that are very conspicuous, that they can see things approaching just as they can be seen. And notice, of course, that they're all facing into the wind, because if they had their backs to the wind, their feathers would be ruffled and they would be a lot colder. And now, of course, there's some birds that have adapted to living with people. This is Rome, and these are flocks of starlings that come in from the surrounding countryside every evening, avoiding falcons, although falcons, of course, follow them into the city, but there are fewer predators in the cities than there are in the country, not likely so many owls. And also, in most cities, it's at least a few degrees warmer than it is in the open countryside. Not to mention, if they're roosting on buildings that have electric lights or anything else, that doesn't seem to disturb starlings from sleeping, but it does add a further degree of warmth. And then, of course, we have swifts. These are Vox's swifts, not our local chimney swifts. And curiously, Vox's swifts have adapted later to using man-made structures like chimneys than the eastern chimney swifts have, but they do now. And then there are other birds like this common swift of Eurasia that spend the entire night aloft. In fact, they spend as much as 10 months aloft. The only swifts that come down out of the sky are the females that are incubating the eggs and brooding the young. Males participate in nesting activities by feeding the young, but they don't ever land except momentarily at the nest. And so young swifts, it takes them 3 or 4 years until they reach adulthood, and adult males are on the wing just about the entire year. They're on the wing in Africa, where they spend the winter perpetually. Whether they are actually sleeping or not is something we'll get to in just a minute. Another bird that spends years aloft is the sooty tern. Sooty terns, you know, are not waterproof, so they never land on the water. They pluck fish from the surface of the water but don't land. The North American sooty terns only breed on the dry tortugas. Perhaps some of you have been there to see them. Those birds winter off the coast of West Africa, and sooty terns don't return to their colony until they're 4 or 5 years old. So those young birds are spending 4 or 5 years aloft, maybe occasionally landing on the back of a turtle or a piece of driftwood, but essentially aloft day and night, and the adults, which are returning annually to their nesting site, they're spending many months aloft. So here's a magnificent frigate bird, and this is the first bird that we know does sleep in flight. The experiments were done in the Galapagos, where these birds are especially tame, of course, and so EEG equipment was put on them, loggers that track their global positioning system and their triaxial acceleration to tell us whether they're in flight, whether they're flapping, whether they're soaring, whether they're riding a thermal. And the frigate birds in the Galapagos were used because, first, they're very tame there, and second, these are birds on the nest, so that when you put this equipment on, you know that when the pair shifts for these 10-day incubation shifts, the bird that they've put the equipment on is going to come back in 10 days, so you can retrieve all of that equipment. And so what they have found was that all through the day, and again, remember that these are seabirds that are not waterproof. They never land on the water. They feed by plucking fish from the surface or, as you know, chasing other birds and making them drop their prey or their catch. So, but we know that by day, thanks to all this equipment, their brains are completely awake, but shortly after dark, they begin soaring higher and higher. They're over tropical oceans where they're thermals all through the year and all through day and night, so they can soar up to 6,000 meters, and they gradually glide down until they find another thermal and rise up again. And what's been found when this equipment has been removed and analyzed is that they do go into bouts of several minutes at a time, unihemispheric sleep where half their brain is shut, and very occasionally bihemispheric sleep with no impairment of their flying ability. When they're in unihemispheric sleep, they're usually circling in a thermal, and it's the inner eye, the side that they're turning on, that they keep awake to avoid collisions. The ocean is so vast, there's so many thermals, the chance that they're going to be in the same thermal as another frigate bird at the same height is pretty low, but they have evolved this precaution. So we also know that they go into a very few short bouts of rapid eye movement sleep where muscle tone is further relaxed and the head just drops onto its neck. But that's very brief. And as I say, the total sleep bout, each of these sleep bouts is only about 6 minutes. They're also, and so let me say this here. So of course, we'd like to know whether other birds can sleep in flight, and particularly whether the birds that are migrating long distances where they cannot land, such as the blackpoll warblers leaving from Massachusetts and going all the way down to the Magdalena Peninsula in Colombia before they land, or the famous bar-tailed godwits going from Alaska to New Zealand, a 7-day flight, 7 days and nights. But flapping all the way. Can birds that flap also sleep? The challenge, of course, is for the godwits, they're fueling up on these Alaskan mudflats. How do you catch godwits and put this equipment on them, and then how do you get them again when they're in New Zealand to retrieve the equipment? It's much easier when birds are coming back to a nest. So perhaps someday somebody will do one of these projects on a bird that does flap for days and nights and likely does not get any long-term sleep, and we'll know more. But logistically, that's a much harder challenge than working with birds on the Galapagos coming back to their nest. So now let's talk a little bit about social aspects of roosting. There's some birds like these Inca doves in the southwest that huddle because they're not well insulated, and this is how they keep themselves warm. And some birds like these, even on an overcast day, will huddle during the day, not just at night for warmth. Pygmy nuthatches in the west, they're small, they seem not to be very well insulated, and as many as 150 have been counted going into a large cavity in Colorado. And in some cases, when there's so many, the birds at the very bottom are smothered to death. But that happens also in bluebirds in bluebird boxes in the winter where they're gathering 4 or 6 or 8 piled on top of each other. Sometimes at the bottom, they can't breathe. When you get to Antarctica, there's another kind of huddling. These are emperor penguins. Their huddles often include more than 1,000 birds, and it's like getting onto a subway. You get on one side. As more people get on, you find you're in the middle, and then you're off at the other edge. So that's what these birds do. They get in on one side, other birds are joining, and the outer edge keeps shifting, and that's when they can exit. So most individual emperor penguins are in one of these huddles for about 50 minutes, 50 minutes, but the huddle itself may last for several hours. And I gave a talk just on Wednesday, and there was a friend who'd just come back from Antarctica. I asked if he saw this. He said no, and I suspect this is something that happens during the Antarctic winter rather than the summer. So few of the tourists who go there are likely to see this. So there are a lot of birds, as you know, that flock during the non-breeding season and roost together. From sparrows to flamingos, there's safety in numbers, there's more vigilance, and it reduces the odds of any single bird being the one that's caught. And these roosting sites can be single species or mixed species. And there's some that are seasonal, there's some that are year-round, and there's some where birds shift from having a territory during the day, such as a certain number of North American warblers in their wintering areas that, like prothonotary warblers and northern water thrushes, two that have been well studied, that go to mangrove swamps and roost in flocks every night, and then disperse and return to their individual daytime territories. And some of these sites, like the ones for British starlings, have been known and used for hundreds of years. So here is the Platte River. Perhaps some of you have been there to see the sandhill cranes. That's probably been going on for thousands of years. And why do they do this? It's thought that this evolved because there were wolves on the banks of the rivers, and the birds were safer in the river than on the land. Another place some of you may have visited is the Caroni Swamp in Trinidad. These are scarlet ibises with a few great egrets. There are scarlet ibises that commute to Trinidad from Venezuela every afternoon to roost here. And there are hierarchies in these roosts, and roosts that are two-dimensional, like the sandhill cranes, especially for shorebirds, which I'll show you a picture soon. The birds that are in the center are in the safest places because the predators are likely to attach at the periphery, and the birds in the center are likely to be more buffered from the wind than birds at the periphery. In a vertical roost like the Caroni Swamp, the birds at the top have the better places because they can escape more easily should there be a predator, and birds that are lower down are likely to be pooped on all night, so that's not so good. In blackbird roosts, multi-species with redwings, cowbirds, rusty blackbirds, grackles, and starlings, there's a hierarchy. I can't remember now which species is on the top. It's also by age and by sex, but there's a real hierarchy among the 5 or 6 species from top of the vegetation to down low near the water in these sort of wooded swamps. So their hierarchy is also about age. It's been well studied in Eurasian oyster catchers, where the best roost spots are on the high tide flats that are closest to the feeding flats. And because your oyster catchers, females are larger than males, females are dominant, and so it's the females that get the best roosting spots closest to the good feeding areas. Oyster catchers take 3 or 4 years to mature, so younger birds are at more distant spots because they're subordinate to adults, and males that are small, which are smaller, as well as any birds that have injuries or other malformations, they're usually at the most inferior of the roosts. There's also a lot of information sharing that's available at roosts. Birds that are coming into a communal roost from a good feeding area that they found during the day, whether it's seabirds out in the ocean or swifts or swallows where they found a horde of insects. The next morning, those are going to leave first and go straight back to the place where they found all this food. Birds that didn't have such a good day the day before will follow those birds and learn where there is food available today. Usually there's no handicap to the knowledgeable birds because whether it's schools of fish at sea or trees that are in fruit or a big carcass, there's enough for all. They don't need to be territorial about that. There are a few birds like ravens that actually recruit birds to join them at a carcass when they've found it. When a new Bernd Heinrich, whose works you've perhaps read on ravens, he's the one who did all these experiments in the north woods of Vermont and Maine. He would lay out a carcass and in the woods, and a raven or two would discover it, go back to their roost. The next morning, they would come back with other ravens from that roost that they had actively recruited because the ravens want more other ravens with them to defend the carcass against other scavengers like coyotes, wolves, foxes. And so they're eager to get a group there. And there are other more insidious uses of roost information sites. Here is a shiny cowbird. You know that cowbirds lay their eggs in the nests of other birds. The shiny cowbird, a tropical species in Puerto Rico, they roost in mangrove swamps with yellow-shouldered blackbirds. The yellow-shouldered blackbirds fly back every morning to their daytime territory. The female cowbirds will be watching the female blackbirds to follow a blackbird back to its territory and watch and see where its nest is, so it can lay an egg there. In Argentina, the same species, also in communal roost with blackbirds, some of the females have already identified a place where they're going to put their egg early in the morning, but other cowbirds don't have a place to put their egg, so the uninformed cowbirds will follow a knowledgeable cowbird back to the nest that the first cowbird intends to put an egg in. The second cowbird lags behind. The first cowbird puts its eggs in, its single egg in, leaves, and the second cowbird comes in, removes that egg, and puts its own egg in. So those are some of the things you can learn at a roost. But of course, the main function of roosting in flocks is to avoid predators, these semi-palmated sandpipers trying to avoid this peregrine falcon. Some shorebirds have taken this to another level on the Pacific coast, and it's also been found on the coast of the North Sea. Flocks of dunlin will fly out to sea for the hours of high tide because at that point there are no suitable flats that are not covered by the tide that are far enough away from other vegetation or things that would obscure the flight of a peregrine coming in at them. So they're much safer going out to sea for several hours, waiting for the tide to go out, where they can then come back and resume feeding at a distance where they would be able to spot a peregrine should one be nearby. So evidently, energetically, they can do this. They can continue flying for several hours over the ocean and then come back and resume feeding immediately. So another example of how the metabolism of birds is quite different from ours. Many of them can go for very long periods without any form of rest as we think of it. Some of the other birds that roost in large flocks driven by falcons are tree swallows. I think this photograph was taken in Connecticut near Old Lyme. There's a terrific place where you can see thousands of tree swallows coming in from everywhere, and then just before it's dark, rising up in a big funnel and plunging down into the Phragmites, doing this when it's darkest so that peregrines have the least possible visibility of them, and when they are flying in a dense mass, so that each one would be harder to catch. In Africa, there are places where wintering barn swallows and other wintering swallows do the same thing, where there are several species of falcons as well as other birds, other predators that come. So while here in North America, the peregrine is probably the major driver of this behavior, in more tropical places where there are many more avian predators that pursue birds in flight, there are many more predators that are forcing this behavior on small, more vulnerable birds. And then perhaps here or in Boston, there are places where you can see these giant flocks of starlings that come wheeling in and take this very wheeling and twisting and turning flight. Again, it's to avoid and confuse falcons who might be pursuing them. So finally, I have to talk about the human impacts on avian sleep, because it's not enough that birds are bothered in all sorts of ways by people and our effects during the day. There are other factors that affect them just at night. So the classic example of birds that are vulnerable when they sleep are all the Hawaiian honey creepers. You may know that these birds are descended from small finches that came from North America, carduline finches like crossbills. And when they got to Hawaii, there were no birds like them, and there were no flying insects like mosquitoes there. So they lost the habit of sleeping by tucking their head on the feathers of their back and tucking their feet into their breast feathers. In the 19th century, when European settlement or American settlement had come to the Hawaiian Islands, casks of water were brought to the Hawaiian Islands from Colombia, and in those casks of water were mosquito larvae. They hatched and they began preying on these very vulnerable Hawaiian honeycreepers. And as you perhaps know, many of the Hawaiian honeycreepers very rapidly went extinct or are now on their very last legs. And the mosquitoes were able to reach a certain level of the mountainous islands and couldn't go any higher because of the temperature. Now that climate change is making everything warmer, they're going up higher, so even the birds at the higher elevations are vulnerable. The other aspect of this story is not only were the insects invasive, but birds brought from Asia had avian pox and various other diseases that were also carried by the mosquitoes once the Asian birds that carried these diseases with them from Asia came to Hawaii, and so now the mosquitoes are vectors for several things, not just avian malaria. So talking about other invasives, this is a cat in Australia with a pale-headed rosella, and of course cats are nocturnal and they prey on birds both day and night, but particularly at night when birds are most vulnerable. And you may have heard some of these figures, but the estimate for the number of birds killed by cats in North America annually, no, just in the US, not North America, is 1.3 to 4 billion every year. In Australia, it's estimated at 377 million. China, the estimate is 2.6 to 5.5 billion birds. So you've probably already heard this many times, but if you have a cat, keep it indoors. And this is just the tip of the iceberg when it comes to invasives, besides the mosquitoes and other insect vectors that carry diseases and cats. Many islands that evolved that have no natural predators and are places where millions of seabirds nest in particular. There are now rats, mice, snakes, mongooses, and other predators that these birds have no defenses against, and albatrosses, for example, on islands where they now have rats and even mice that are nibbling at them, they just don't know what to do. They just sit there, and overnight they're killed. So then let's think about some other human impacts. Here's a flock of sanderlings, and this would be a good example of why the dominant birds should be in the middle and the subordinate birds would be out at the edge. They need high tide beaches to roost when the flats where they're feeding are covered, and recreational disturbance is a big problem for them. Sanderlings, as you know, the peak time that they're with us are during July and August, which is of course the peak time that everybody wants to be on a beach, and so there are very few beaches that have places that these birds are left undisturbed, particularly at beaches that allow vehicles, allow dogs, as well as people. So it's a big problem, and of course climate change is making the availability of exposed flats where birds can spot predators at a distance fewer and fewer. And finally, there are the effects of artificial light and noise. This is a European robin. A lot of birds are now living in places where the lights are on early in the morning for them, late at night for them, and we know that they change their behavior, or at least certain species do. Robins do. Robins, these European robins, they will start feeding earlier when when they're in city parks or other places that have lights. We don't know that that's actually deleterious to them. We do know that for the birds that have been well studied in Europe, even though they have more hours in which to feed during the nesting season, they're not using those additional hours to bring more food to their young. They're simply spreading out their feeding over the additional light hours. So we don't know that it's a problem, but we know it's having an effect. And likewise, artificial noise, we don't know that it's a problem, but we do know that birds are changing their singing schedule to avoid times with a lot of noise, and they're also changing their pitches at which they sing so they can be singing at a way that's transmitted that doesn't get drowned out by artificial noise. So a lot of work has been done at the airport in Madrid, where the first planes land and take off at 6 in the morning. The birds that nest around in the woods around the edge of the airport, they have begun singing earlier in the morning to sing when they're not in conflict with the noise of planes coming and going. But again, we don't know that this is having any deleterious effect. We simply know that it's an adjustment that they are making. So I want to close by coming back to the beginning and asking you, why do birds sleep standing on one leg? Any ideas? I can't really see in the dark if there are hands raised. Nobody? Exactly. So the best work on this was done at the Philadelphia Zoo, where the colder the day, the more of the flamingos in their captive flock kept one foot up against their belly feathers. And for flamingos and perhaps some other, well, flamingos especially, that live in at least the Rift Valley, for example, or the Andean lakes, are living in these very alkaline lakes. All of that is probably irritating to the skin on their feet, and so the time that they spend without it being exposed to that may also be a benefit. But it's the cold that is the main driver for them and for a lot of other birds. This has also been watched and studied in long-legged shorebirds, that the colder it is, the more often they will sleep standing on one leg. So I'd be happy to answer questions of any other kind, and in closing, I simply invite you, when you go to bed tonight, just think about what birds are doing and the challenges that they have had and the ways that they have evolved to meet them. Thank you.
Thank you so much, Roger, for delving into such an important topic for birds, and especially thinking about, for some species, how much time they are spending either asleep or at rest. And it feels like the kind of book that raises lots of questions as you're reading it. Is that true?
There's still lots more to understand. Certainly the question of can other birds sleep while they are flying is one. How much rest do birds really need? We know that those godwits and other long-distance migrants, a lot of this work has been done in the Waddenzee in the Netherlands, where birds are flying up the coast of West Africa to the next stop that they land in is on the Dutch coast. The first thing these birds do is rest, and they sleep for a couple of hours before they go out to feed. You'd think that they'd be starving as well as tired, but fatigue is the first priority to relieve.
Right. Okay, here.
So, of course, we expect birds to choose places to live based on good habitat, food sources. How about roosting sites? How much does that drive where birds choose to nest?
Well, let's separate roosting from nesting for a moment, because roosting is something that they have to do all through the year, while for many birds, nesting is just a matter of weeks or a few months. So, and of course, they may be moving to a completely different area. Think of all the migrating birds that are not roosting in the same place the rest of the year in the same place that they're nesting. But for a lot of birds, there is a real shortage of good places to roost, and that's why many birds do roost in flocks, because the places that have the features that they need are in short supply, and that's why they congregate at these spots, whether they're in tidal flats or swallows in sort of wet marshes that animals that would approach through dry ground couldn't reach them. So but to come back to the other part of your question, for nesting, most birds roost within that are territorial, roost within their territories. But I know that wood thrushes, while female wood thrushes are spending the night on the nest, male wood thrushes in territories that don't have as thick vegetation as they would like leave their territories and roost someplace off territory and then come back early in the morning. And there are probably other birds that do that as well. So there may well be some birds whose territories don't have the best places to roost within that territory. There may be other birds who are deliberately rejecting territories that don't include those features.
Great talk. You mentioned torpor and hummingbirds in the Andes. Mm-hmm. Do you have a sense of what percentage of those hummingbirds are entering torpor in an exposed area, or as opposed to in crevices or even in caves?
A good question, and I think for the Zoom people I should repeat these questions if they don't hear them very well. The question is, what about hummingbirds in the Andes or other high elevation places that may or may not have, how often are they roosting in the open and how often are they seeking shelter? There are a lot of birds in the high Andes, not in hummingbirds included, but some other birds too, that roost in caves and glacial crevices because they're less exposed to wind there and it might be slightly warmer than out in the open. But most of the hummingbirds in the higher elevations are in places where there aren't glaciers. They're not that high. There may not be caves, and so they are roosting out in some place in their territory, and their territory at the high Andes, there are no trees up there. There's probably nothing that's giving very much shelter, so it's mainly a matter of lowering their body temperature to do the job that a sheltered spot might, for other birds, keep them from having to do.
Should I just do this? Is there any evidence that birds dream?
Good question. So the question is, do birds dream? Nobody has yet found a way to determine that, but what has been found is that some birds at Rockefeller University, where they're raising a lot of zebra finches and other small birds to study how they learn birdsong, have put the EEG equipment on them at night and found that some of the patterns in their brain waves while they are sleeping replicate or are the same as the patterns that these birds have while they are singing. So it may be that at some level they are rehearsing, if you will, what they need to do, what their brain needs to be doing while they're singing. But that's as close as we have come to anything that we could call dreaming, because of course we don't really know what a bird's dream would be like. Yeah, here's a question, 2 rows down.
Yeah, and the just as long as people are using the mic, you won't need to repeat the question.
Yeah, is there anything we can do in our backyards to help with birds roosting?
Sure. Most of the birds that you could help are the ones that would want dense vegetation that's dense through the winter. So different kinds of conifers will attract birds to sleep. If you're living in a place where nearly everything is deciduous, some sort of holly or yew hedges or something like that could help them. If you have bird boxes out, there are many small birds, such as bluebirds that I mentioned, that will roost in boxes just as they would in natural cavities. So you could increase the roosting opportunities for cavity roosters that way. Those are the first 2 things that I can think of.
I'll jump in here too. I was curious, what was the most interesting research since publishing the book? Because I know you were saying This is a very active area of research that's going on. Is there something that you feel is particularly fascinating that's come out?
Well, the last research that I could do before this book went into publication phases was the end of 2023. Since then, I've been working on another project where I have had a few reasons to scan the ornithological literature for my current topic, and I have found other things that I wished I had known to put into this book. But as a kind of defense mechanism, I've pretty much forgotten what they were because it'd be too irritating. But I will say that I think the very last thing that I found before I had to stop reading was somebody who was working on black swifts in Amazonia where they winter. the genus Apis and what used to be part of Apis, like the what used to be Apis melba, I can't think what it is in English. Oh, the alpine swift. And then some of the needle-tailed swifts, those are old world swifts that are known to spend the nights aloft all through their non-breeding season, and the ones who are not nesting during their breeding season. But somebody working in the Amazon published in 2023 that black swifts, which of course we have in the West, they also spend the night aloft. So that got me thinking, why is it that some swifts, like the chimney swift, roost in huge flocks in the non-breeding season, while during the breeding season they just nest in very small groups in chimneys or hollow trees, and other swifts are aloft? It may be that for these larger swifts, the needle-tailed swifts, Caudacutus is the now, Horundipus is the genus for them. It may be that there aren't enough good roosting spaces for birds that are as big as they are. I mean, these birds, their bodies are about this big, which is bigger than chimney swifts. There may not be suitable spots where they could be safe. So roosting in the air may be the best solution for them, just as there are other swifts in the American tropics, perhaps elsewhere too, and actually in the West isn't the white-collared swift that nests behind waterfalls, so and would roost behind waterfalls. But for some of these larger swifts, there may simply be no other space for them. So it was interesting to know that a Western Hemisphere swift, not at all closely related to the well-known aerial roosters of the Old World, is also doing this. So that was the most recent piece that I was able to squeeze in, but I've tried to forget the things that I should have known but couldn't know.
So I was curious about grassland birds or birds of open country where there isn't any good hiding places. Do we know anything about where they sleep?
Well, yes. Well, if you're in a grassland, really they're just two dimensions, and probably roosting closest to the ground is the safest thing from them from aerial predators. If there are many ground predators, as there are in the western prairies, for example, you're probably safer off roosting as high as you can, perched in the grass, if the grass will support you. But that's perhaps one of the reasons that some of them move to marshes where at least it's wet on the ground. The ground is in water, so there are not as many ground predators that could approach, while they can perch higher up in the reeds, which are also sturdier than grass stems, and use those. But sparrows, larks in the Old World, they often sort of scrape out little cavities in the ground so that they are sort of flat against the ground and not as exposed as a raised body on the ground.
I'll ask you one question before closing things up here. What's a question that burns for you after having done all this research that you feel like hasn't been adequately answered by the literature or the studies?
Well, I think we've had some of those questions tonight. It certainly would be interesting to know what goes on in birds' minds during the night, and then, of course, how do these birds that are awake for many days at a stretch, what kind of rest do they get, or what kind of rest do they actually need? I think those are two of the biggest remaining fields to hope that future research and future technologies can tell us about.
Yeah.
So we do have copies of the book upstairs, and I hope that the person who's in charge of doing payments only by credit card has mastered her machine that had some problems before.
She's found an end around.
Oh, good.
Leela reports that you can do whatever signing, personalizing.
Okay.
I know they've been signed. And then people can bring them to the register that's at the shop. So I think that's it, right? Okay.
Great. So I'll be up there at the table, and any of you who'd like to get a copy of the book and have me inscribe it, I'd be happy to do so.
And ask questions.
Yes.
Thank you again, Roger.
Okay, thank you.
That was such a fascinating talk.